Okay, so this is Actex 929, and it states an automobile insurance company divides its policyholders into two groups, good and bad drivers. The good drivers have the amount of an average claim is 1,400 with a variance of 40,000. And for the bad drivers, the amount of an average claim is 2,000 with a variance of 250,000. 60% of the policyholders are classified as good drivers. Calculate the variance of the amount of a claim for the policyholders. So, cool thing is that we know that the policyholders or policy is basically divided between these two. There's already told us that the proportion of G is 0.6. So then we know that the other half by the complement is 0.4. Now, every time that we have this particular policy and we're looking at it for the average, we already know it's a claim. So everything that we see here is already a claim because we wouldn't have an average for it and we wouldn't have a variance for it unless there was a claim inside there. So every claim is weighted between 0.6 for a good driver, plus 0.4 for a bad driver. And only thing we need to know is they want to know what the variance of C is. Okay, well, the variance of C is equal to, what is our regular rule? The expectation of C squared, second moment, minus the first moment squared, right? We know this, okay? But let's find the first moment, all right? But before, well, we'll go ahead and do it because it's really easy to find the first one. The second one's a little harder, as you'll see here in a second. So the expectation of C is 0.6 times the expectation of x to 1, which is good driver, right? Right? We could just say that. I can say G. That's fine. Right? Plus 0.4 of the bad driver. Right? Well, that's 0.4 the expectation of G. 1,400 plus 0.6, 2,000. Voila! We can calculate that bad boy pretty fast. What? Oh, I messed up. Okay. This is supposed to be 0.6, and this is 0.4. And then it should be 1640. Voila. So now we have the first one, but we gotta find the second one. Well, for us to find the second one, it means, because this is weighted, this is awesome, right? I need the second moment of G plus the second moment of B. How I find those? Use the variance, right? So, we know that the second moment of G is equal to the variance of G plus the expectation of G squared. That will be the exact same for our B2, but obviously using B. Not to get confused, I know the variance of G is 40,000 plus expectation 1,400 squared. Variance of B 250,000. Somebody hit something pretty bad. That's pretty high variance. Comparatively, see how close they are to the expectation. Somebody really hit somebody pretty hard. That is hell of skewed that way. Alright, so let's find out our second moments. We need those second moments to throw them into the weights. So let's do 40,000 plus 1,400 squared. Okay, I've got 2 million. Next one is 250,000 plus 2,000 squared. 4, 2, 5, 1, 2, 3, 4. 4 million. Okay. That makes more sense. Alright. So, second moment would be 0.6. G is 2 million. $4,250,000. Okay, let's see what we got. And then, because I'm going to do this all the calculator, I don't want to waste too much time. We'll throw it all back in to find out what the C is, which is this number here minus this number here squared. All right, here we go. Like that. I could be wrong with too many zeros, but I'm not gonna care. I'll let you guys figure it out. That will be the answer. D. So what we learned here is that we need to set up we need to set this up here, knowing that it's equally weighted distributions. They automatically gave us the expectation, which is awesome. So that's easy to find. We usually find that pretty easy. Then it's the second part of it. We have to think about, hey, we have to do C squared. And then C squared will help us find what the variance is as well. But remember, C squared is we have to find those second moments there.
Did I interrupt you?